and let's get some people to join us. What do you think?
Go for it.
All right. All right. So we have gone live, and we'll give people a few minutes to join us on this cold night. See, here's a really good reason why webinars are really great. Like normally we would be having to go out, right, to a venue to have our backyard forestry. We get to stay home in our nice warm houses, right?
With
So,
your swimming pool.
and go to my swimming pool, right? Yes,
Right.
it's summer all the time where I live. I wish. So for those that are joining us, welcome. We're going to get started in just a minute. We want to give everybody time to join us. And I know I have my ice water like I always do, but I do actually have a cup of tea, a nice warm cup of tea ready.
And today's the first day of winter.
It is, and it's not officially
Not yet. Not
right?
yet.
It's 10 something or
And
another.
something, yeah.
Yeah. And it's the shortest day of the year, right?
Yeah.
So from this point on, spring every day, it's one more day closer to spring.
That's right.
Which I love. So,
this is iced tea, by the way. So.
oh, it's iced tea. Did you get me one? No, I have to go to decaf or water or
Okay.
After 5. So, and I did a foolish thing, and I have this watch face on my Apple Watch that actually tells you how many days left till Christmas. I didn't realize how stressful this actually is. So just in case you were wondering, according to my watch, it's 4 days till Christmas. So
Okay.
Coming quickly.
Coming quickly.
I did some last minute shopping today.
Oh, good for you, Rich.
Well, it's interesting because I had a chance to sort of deliver a Christmas message online where there were like 50 people online and everybody was grumbling. And I said to everybody, just mellow out. There's a lot of bad things going on in the world. We're very lucky to be online.
Yes,
You know,
yes,
and
there you
everybody
go.
started sort of getting on board and saying
Oh,
hello to each other and that kind of thing. It changed everything. So it was a
I
great
love
day.
it. I love it. That's terrific. Yeah, we have a lot to be grateful for. That's for sure.
No doubt.
All right, so we're going to get started because it is a little bit after 7. So again, welcome everybody to this month's Backyard Forestry in 90 Minutes online. My name is Lori Jensen. I'm the Executive Director of the New Jersey Forestry Association, and we're super glad that you're here. So we're going to get started, just have a quick little introduction, and I wanted to tell you about some of the things we have going on. So a little bit about upcoming programs. We actually do this every third Thursday of the month. So save the date, every third Thursday of the month, Backyard Forestry online. If you got notification on this, we'll make sure you get notification of future programs, and we hope to see you then. However, if you did miss a Backyard Forestry, not to worry, because we actually put them up on YouTube, our YouTube channel afterwards. So feel free to subscribe to the New Jersey Forestry Association, and you'll be up to date on all the great presentations, and you can go back and look at some of the ones we've done in the past. In addition, we started doing these walks in the woods, we're calling them, and they've been super successful. We did what I think it was 3 in November, right?
In November.
Yep. And there are more walks coming soon. So again, if you get our emails, you'll hear about those. And finally, put this date on your calendar because it's weird seeing 2024, but March 16th, 2024, we're going to have an in-person annual meeting of the Forestry Association, and that'll be at Rutgers Cook Campus Student Center. So hopefully we'll see you there in person. And then I'd like to introduce, we're fortunate to have our Vice President with us tonight, Rich Kelsky. I'll let you take it away.
Well, welcome everybody to the New Jersey Forestry Association's Backyard Forestry Series. Tonight we have an extraordinary presentation, and you'll be meeting a very, very knowledgeable individual. And I think in 1 minute before this started, we learned more about bark than probably we knew in our whole lives, and that was just in 1 minute. So this is going to be great. So I thought I'd take a moment to let you know a few things about the New Jersey Forestry Association. First of all, it's a 501c3. We're a small conservation organization, and I would say with a very large footprint. We're the only statewide voice for forest landowners, public and private, and we have extensive resources in the practicing forestry community and with their scholarly scientific counterparts. We produce programs like this, and our Walk in the Woods programs and our Woodland Stewards program. We monitor, analyze, and comment on legislation and regulation, and we conduct educational outreach efforts. But all of those are expensive and labor intensive. We support science-based active forest management of New Jersey's forests to help ensure resiliency, diversity, sustainability, animal habitats, and recreational resources in the face of major challenges such as climate change, weather events, invasive species, pests, diseases, wildfires. I could go on and on. Most recently, we were successful in our grassroots campaign to preserve the future of science-based forest management in the Highlands region. And we also were very pleased to serve as one of the 4 co-chairs of the New Jersey Forest Task Force. If you have not done so already, please join our association or donate to it and consider participating on one of our committees or applying to join our board. Thank you for being with us this evening, and I'll turn it back to Lori.
All right. Thank you very much, Rich. And for those that didn't notice, there's a little QR code here. So if you take a picture of that, you can actually go right to our website and join. And we appreciate the support. So without further ado, it is my pleasure actually to introduce our presenter tonight. So Bruce Crawford is the manager of horticulture over at Morris County Park Commission. He's also a board member of the New Jersey Nursery and Landscape Association. And he's going to kill me for saying this, but he's also the host of this public-facing cable TV program called Growing Green. So we have a lot of fun doing that. And it's just trying to make gardening and all sorts of horticulture exciting for the public. So Bruce, without further ado, I will stop sharing this and we'll get your PowerPoint up. So how you doing, Bruce?
I'm doing well. How are you?
No, so no raising the bar there as far as, we learned more in those 30 seconds, right? So
yeah, right.
Yeah. Okay. And you're able to now hopefully control the
Yes.
PowerPoint.
So killing my image, so I save my bandwidth because I am out in Warren County and I work off of a hotspot. So I lost a little sleep this week. I was hoping this would come through, and Lori has done a great job. So it's all working out well. For years, I've been fascinated with bark. 30 years or so ago, I gave a presentation with a friend of mine, and we sort of likened bark to the legs of the plant and how the different approaches of looking at the legs. And I always think it's fun to look at bark and plants in terms of human anatomy. And I just think it adds sort of a touch of personalization to it. So, we'll sort of approach it from that angle. Everyone has looked at the inside of a tree. I mean, everyone has seen the rings of a tree. Everyone sort of looked at it, but you don't really understand. And to be honest with you, scientists don't really understand a lot still about how trees work and operate. So it's still an ongoing process of learning. And so no one knows all the answers, and it'll be years, I'm sure, before everyone does, if it ever happens. But when we were looking at that previous slide, what you saw in the center here, you saw all those rings. And as I'm sure you know, the more light colored rings are the early season of growth, and the darker portion is the slower portion of growth during July and August. So that's the summer growth. And if you've ever chainsawed a tree, you'll notice that as you go through it, you'll notice that there are soft and easy to cut parts and harder parts. And so the denser summer parts are obviously more difficult to cut versus the lighter spring growth. So even if you cut a tree, you've sort of experienced what it's like of the development of the tree. And when you look at the center of the tree, we'll look a little bit at plant anatomy here, physiology. You have heartwood at the very center, and then you have sapwood around it. Both of these are called xylem. And the heartwood, the reason that it's different is that it doesn't conduct water. And that's what the sapwood does. It conducts water up and down the tree. But if anyone knows Jason Grabowski, who's, I think, one of the best tree people I know, as he so eloquently put it once, trees don't poop. And so what did they do with all the metabolites? What did they do with all the stuff that they can't get rid of? They put it into the heartwood. And so that's why heartwood is sometimes a very difficult area to decay and rot because of all of these metabolites. So so it doesn't conduct water, but it's often very rot resistant. It's usually in white oaks and in bald cypress. It's the older wood that is the decay resistant, and the younger wood, which is sapwood, is not. So that is the inner part. Then you have the vascular cambium. So the vascular cambium produces the xylem to the inside, and it produces the phloem to the outside. And the phloem is what allows the sugars from the leaves to be conducted down to the root system, and vice versa. In the spring, it sends it back up to the upper part of the tree canopy for it to develop the new leaves. Outside of that, you have secondary phloem, and then you get into the cork cambium. And that's what we're going to be talking a lot about tonight, is that cork cambium. And it's oftentimes called the periderm. We'll talk a lot about that too. So as we venture on to the next image. So that's it. The vascular cambium produces the xylem and the outer phloem. The outside of the phloem produces the secondary phloem. And this is all stuff that I didn't really learn in botany back in the 80s, or I forgot about it because it was really boring. But as the more you get into the trees, you find out, wow, this is sort of cool. Outside of the secondary phloem is the cortex, and in seedlings, there's the epidermis. And as the stem starts to grow, it starts to push pressure against the cortex and the epidermis, and they start to split. And for reasons unknown, it starts to develop the cork cambium. So, and that's the dog in the background barking at the wall, as he usually does. So, the cork cambium produces this the cork, and it produces the phloderm to the inside, and it produces the cork to the outside. And you go, okay, and where are we at? Here we are. So the cork so phlo is Latin for bark. So you're going to see a lot of P's in all of this, and it comes out of the sort of the Latin. But the cork cambium is in the middle, produces the phloderm to the inside. And the interesting thing, which I found out as I was starting to research this a couple of years ago, is that a lot of the inner bark is photosynthetic. And so we'll be talking about a lot that tonight. The cork that is produced to the outside quickly dies. And so it has a waxy coating to it. So the reason for that obviously is that one of the main reasons for bark is to prevent water loss. That comes as no surprise to anybody. So so as the xylem continues to expand from year to year, it obviously pushes against this cork cambium and the whole periderm, and it starts to fracture a little bit. And so as it does that, the cortex or the secondary phloem, and it depends on plant to plant, or genus to genus and species to species, which it's either the cortex or the secondary phloem. So there's never a set way bark is produced. Each plant does it differently. So that's one thing to sort of recognize. But as the xylem expands, it stimulates the production of another cork layer and another cork cambium, and that produces another periderm layer. So you start to develop a buildup of outer bark, and that outer bark is called the rhytidodome. And so that's what we normally see when we look at bark. It's that outer dead layer. And what fascinates me is that even though it's dead, it's still expanding. And that's the fun part of trees. And how do they do that? So that's what tonight is really all about, is looking at different trees and how they accommodate that expansion. So, and as I mentioned, the cork cells, they're often formed in layers, and they produce a waxy substance called suberin. And again, that reduces water loss. And it's really that relationship between the older periderm and the younger periderm that's being produced beneath it. And so the older periderm being called the rhytidodome, that gives you that appearance of the bark. So in essence, that outer layer, is it tightly connected to the newly developing paraderm beneath, or is it loosely connected? So if it's really tightly connected, then it starts to split. And so if you look at persimmon, which we're looking at here, that's what causes that ridged and furrowed appearance. As it expands, the bark literally splits. And there is, and not to worry, so there's what they call dilation meristem. It essentially produces undifferentiated cells, or cells that really don't have a function other than to fill the cracks and the holes. So it's rather complicated, but at the same time, when you have that tight connection, you have that bark splitting like you see here, and it develops that. If the outer bark is loosely connected to the paraderm, then you have exfoliating bark. And this is what I really love. And I love the fact that the bark is peeling off the tree. And I've always been fascinated by that. And I've always thought, gee, what a waste of bark. I mean, the tree is just exfoliating or giving off all of this material that it's had a hard time producing. So why would it do that? And it simply made no sense to me. And if you go up into New Hampshire and you start to see some river birches or paper birches we're seeing here, the layers are actually built up with, and they have alternate layering of suberin. So one layer has the suberin coating on it, the next layer doesn't. And as a result of that, they peel off in sheets, like you see in paper birch or even river birch that were used popularly with landscape materials. And then you have smooth bark trees like beech trees. And of course, beech trees are in trouble right now. But the interesting thing is that the original cork cambium continues it doesn't build up in layers, and it doesn't slough off or peel off. It remains for the life of the tree. And that what gives you that nice smooth bark to it. So again, each tree is developing a totally different structure. Now, if you've ever had I think the fortune of being able to go out and see some of our wonderful parks, which we're going to sort of focus on a little bit tonight. We're out in Moab. This is Arches National Park. That's my daughter. And so we always go as a family. We do a trip every summer. And this is obviously very early in the morning. And so it's not too hot yet. And then if you go a little bit outside of Moab and you get up to about 6,000 feet, then you have your aspen trees. And if you look at them, the bark obviously is very white, but it's slightly green tinted. And so that is the phylloderm underneath, which has photosynthetic abilities. And when you think about it, these are in very cold environments. And as a result of that, they lose their leaves early. So how does the tree produce sugars to sustain itself? And so it developed photosynthetic bark, which I just think is fascinating. Because you always think, as from a kid, it's the leaves produce the carbohydrates and the sugars, and that's it. But in these situations like this, it's the bark that's taking on the photosynthetic abilities, because for such a long period of the growth of the tree, there isn't foliage on it. So I just find that totally fascinating. And if you look at the older portion of some of the trees as they age, it starts to develop this corky bark to it. And you think, well, why? And the reason is now it's down low, it's getting shade, so it's not as efficient as in photosynthetic abilities. So then it starts to produce this protective coating. So when you look at bark, I look at it from a bunch of different ways, and this is just my sort of breakdown of it. You could subdivide this even further, but I thought we'd look at trees tonight that have this type of structure, and how they, when you look at them in the landscape, what are they? And I always find exfoliating bark to be one of the most interesting and fun to look at. And so here we are at Wave Hill. If you have never been to Wave Hill, I thoroughly recommend it. It's in the Riverdale section of the Bronx. We're looking at the Palisades and the Hudson River off in the distance. Take a drink of water here. actually iced tea. And right in the middle there, slightly to the right, that's Acer grisseum or paperbark maple. And it's one of those trees that back in the 80s when I was learning trees, it was very difficult to propagate. They were having difficulties propagating it from seed. So you didn't see it all that often. It was a rather rare tree. And it was a beautiful tree for that golden color of the bark. And it varies tremendously. So here we are down at the Scott Arboretum on the left-hand side, up at Smith College on the right-hand side. And when you look at it a little bit closer, you see these lines on the little dots. And again, the bark is peeling, much like river birch, and most likely due to the fact that it has alternate layers of suber-enriched paraderm or cork and non-waxy bark or cork. And but it's these lenticels, and lenticels are sort of an open. The cells have more space in between them, and it allows airflow in between. And this allows, obviously, oxygen to come in and for the plants to respire and for the plants to grow. Because you always wonder if you really had a solid bark on the outside that didn't allow any air inside, then where is the oxygen coming from for the cells to respire that are actively dividing just inside the bark? So somehow they need a window in which they can get oxygen in and CO2 out. And that is the job of the lenticels, and which I just, you look at it, they look like nothing. And the other interesting thing about lenticels is they're found in every tree, every plant, fruit, apples, pears, potatoes. Wherever you look, there are lenticels, but you don't notice them because some of them are more prominent and some are less prominent. So look at that bark. I mean, absolutely gorgeous. So when you look at the function, there's an exchange of gases in between. And what's not obvious is that all the fruits, as I mentioned, have lenticels and woody plants. And then look at where they are. So here we are at the base of a branch, and look at the population of lenticels there. I mean, look at that. First you look at it, you go, oh, that's scale, but it's not scale. Those are lenticels. And why would there be so many of them at the bottom of the branch? And again, this is where you're developing all that structure to support the limb. So the image on the right is of a tree which was put through a bandsaw, but it shows you the structure that's developing underneath the pith that is going to be supporting the branch. So you typically have more development underneath the stem than you do above it, because that's actually what's holding up the branch. And when I cut this plant of, this is Macchia, the center of the branch obviously is way high on it. So all of that wood that's being developed underneath it is to support the branch. And when I cut this branch, I looked at it, I was like, well, that's odd. And then I thought about it for a second. I was like, no, that's not odd at all. That makes total sense. Plants are great engineers. So that's why you typically see all these lenticels at the base of a bark. But again, looking at peeling bark, here you have Acer triflorum, the three-flowered maple. This is a great little tree that just doesn't seem to be getting the use and interest that it should. Its bigger brother, so to speak, Acer grisseum, seems to be taking the brunt of the interest. But again, if you look at the bark really closely, you're going to see those lenticels, and you see how the older bark flakes off. And again, why would the older bark flake off? And part of the reason probably is that the older lenticels or outer part gets shed, so the lenticels become more efficient. Doesn't work for every plant, but that would be one reason I would see for doing that. And you can see the older lenticels on the outside that are being peeled off with the bark, and the younger, rather attractive ones on the inside. So this is still Acer triflorum, three-flowered maple, and a great plant for up-close interest in the landscape. And is not invasive, nor is paperbark maple, Acer grisseum. River birch, got a great plant. When I was, the first time I saw this as an old plant was up at the Arnold Arboretum. And I saw it from a distance, and it was 80+ feet tall and had dark, dark black bark. And I couldn't figure out for the life of me what the tree was, because when I was taught the plant in college, it was, oh, they were always young plants which had cinnamon exfoliating bark. And so I never put two and two together that nigra, which of course means black, refers to the bark, which as it ages. So, but when it's young, it has this wonderful exfoliating appeal to it. And again, the younger wood is exfoliating. There is photosynthetic periderm underneath it. So, and it's only the youngest wood which is photosynthetic. And it all makes sense, because when you think about it in a forest situation, it's the youngest wood that's going to be highest in the canopy, that's going to be receiving the most sun, that would then be the most efficient at producing carbohydrates. The older bark, becomes protective, develops thick and ridged and furrowed, because again, it is now less efficient because it's on the ground plane and doesn't get the sunlight. So the plant is an extremely efficient beast for making sugars and carbohydrates. And that in part relates to really rapid growth. So if you always wonder why river birches grow so quickly, that's one of the reasons. One of the things that I have a pet peeve about, which I always like to mention at least, is that oftentimes they're grown as multi-stem trees. And in the wild, this can happen if a given tree is accidentally cut to the ground by whatever force of nature. But oftentimes nurseries will put 2 or 3 individual stems in a container and then grow it as a multi-stem plant, when in actuality, it's 3 or 4 individual plants. And over time, the plant starts to split open like you're seeing here. And I always worry, what's going to happen when this tree develops into an 80 plus foot tall structure, and it's going to start to, I would think, start to fail. So I like to see them more as a single stem specimen, as you see here. This is at Central Park. But, and again, see, it's starting to develop that nice, thick, dark black bark to it, but still very pretty. Anyway, cool plant. Taking a sip. So this is Cornus cusa, Chinese dogwood. This is a plant that I nicknamed Patches. It's down at Rutgers Gardens, Rutgers. And obviously it has wonderful bracts to it. These aren't petals, actually. These are modified leaves called bracts. And they're pointed. The true flower is actually in the center there, which is green. So it's the bracts that are attracting you. The fruits are much different than our native, and I think are highly ornamental. The fall color is fantastic. I always love that. But it's the bark that I always loved. And this is why I called the plant Patches, because the bark flakes off in patches. And just thought it was fun. But when you look at other ones, again, you can see there is a sort of a greenish hue to the plant. So again, it has photosynthetic bark. And as the older bark, the periderm builds up, as it expands, it peels and pops off and reveals the inner bark. And again, you see those little white dots that are on there. Those are the lenticels. Cornus florida, by contrast, slightly different shaped bracts, but same concept with the flower, the green flower in the center. But the bark becomes platy. So it has a very, the outer bark is very well attached to the inner bark. So it tends to develop this checkered look and not the exfoliating look. So totally different in appearance. And I always think it's interesting is that when Elwin Orton crossed the two species, our native dogwood with the Chinese dogwood, and there's Elwin there a number of years back. I got to know Elwin well. He was my advisor in college from 80 to 83. And this is what the bark looks like on the crosses between the two. So it is sort of in between, and it's still exfoliating and peeling, but not to the degree of Cornus cusa. So somewhere in between the two. But still, I thought it was interesting how the genetics work there. Macchia, an interesting plant, comes from the Amur River Valley. This is up in northern China, against Siberia and Russia. But it produces white flowers in July, which are attractive to pollinators. It's in the pea family, so it grows in really poor soil conditions. Produces a lot of seed pods, but both at Frelinghuysen Arboretum in Morristown and Rutgers Gardens, New Brunswick, we didn't have any issues with seedlings forming. But I love the bark on it. Great detail, and it exfoliates lightly, and again you can see the lenticels in there are quite attractive. But still, that little bit of a curl to it, I just think is fun. And again, you can see the green underbark there. So again, plants like this, which is growing in zone 4 and zone 3 environments, a lot of the year is spent without foliage, so it has to somehow subsidize the lack of foliage, so it produces the sugars through the bark, and which I just think is just fun. Persian ironwood, another plant that I've always appreciated. One of the biggest specimens in New Jersey is down at Rutgers. But the flowers are apetalous. You just have the anthers hanging out on it. Blooms very early in the season and gives a sort of an orangey or purplish glow to the plant. Look at the leaves when they come out. I mean, they have a purple margin to it, which I just think, and it's in the witch hazel family. So that's why the leaves look very much like witch hazels. It's not invasive. It doesn't seed around. It's one of the few plants that I know that's hardy in New Jersey, which will self-graft. So if there is a branch or a stem next to an adjacent, the two will graft together. And that will, for a multi-stem plant like this, that again gives a constructive advantage and enhances and strengthens the architecture of the plant. So it's sort of like a cross member put across, so that as the plant stems grow in diameter and start to push against each other, the stems that have sort of glued together are holding the structure in place. And again, a lot of suckering wood on the stems, which we keep cut off. But still, I think an ultimate plant. Now, another advantage to exfoliating bark is that it gets rid of egg masses that are on the bark for the wintertime, and it gets rid of lichens. And I can sort of think of lichens as being this itchy thing on your skin that you'd really like to get rid of. And here's how the plants get rid of it. I mean, they just sort of peel it off and get rid of it. So again, you look at peeling bark and what are the advantages to it? Not only is it bringing out the underbark, which is more photosynthetic, but it's also getting rid of potential hazards such as insects or lichens. And look at that underbark. So again, this is Perodia. This is one in my front yard. It's one called Vanessa, which has more of an upright habit to it, but it's growing in really poor soil and just thriving. It endures drought. It'll grow in high pH, low pH. It will sucker, which is what it does in the wild. So it'll actually produce colonies. And if you don't want that, obviously just remove the suckers from as close to the root system as you can. And there's the fall color of it, that big yellow plant to the right of the building. That's Perodia persicans. Can lichens cause adverse health effects to plants? No, that's sort of a misnomer. I knew one gentleman who actually went out with a power washer and power washed the trees to get rid of the lichens. What lichens do show you is that the air is clear and has less pollutions or pollutants in it. So lichens are actually something not harmful and are actually telling you that you're breathing good air. Our native sycamore tree develops to be a huge size. Obviously, at the base, it has darker bark. But when you look at the upper bark, it's very white and bright and showy. And so this, again, has photosynthetic bark to it, which if you ever wonder why sycamores grow so quickly, this is one of the reasons. It also, certain bark will develop fibers in it. And typically, the fibrous bark will peel off more in strips, whereas the bark that doesn't develop fibers, like Cornus cusa and Perodia and sycamore, they pop off in patches. And so that's what we're seeing is that lack of connective fibers. So, but as you look at, as they get closer to the ground, this is a tree at Willowwood Arboretum. You can see the bark becomes much thicker and less photosynthetic and less exposure to the inner bark. And then Stewardias. Boy, do I love Stewardias. This is what it Frelinghuysen. I remember when my kids were, both of my sons were little, and I'm meaning little, I'm meaning 5 and 8. I said, "Do you want to go to Dad's playground?" And they were like, "Oh, yeah. We want to go see what Dad's all about." So I took them here to Frelinghuysen Arboretum and started to show them the trees, and they're like, "Dad," and I was like, "Where are the toys?" And I'm like, "This is it. Look at the bark. Look at that." And I've got a picture of them. It's a slide of them staring at this bark and totally, not comprehending what Dad was looking at. And I think I started them off on the wrong foot as far as arboretums go. But anyway, so this used to be called Stewardia pseudocamellia, but that's now all the Stewardias or pseudocamellia and coriaena are now lumped under coriaena. So pseudocamellia used to be from Japan. Coriaena obviously was Korea, but they think now that they're one and the same plant. I saw a question on how fast do sycamores grow. They can grow 3 to 4 feet a year, so they can grow very rapidly. Look at the bark, though, on that Stewardia. I mean, you cannot help but like that. I mean, camouflage bark. Like, initially, I was always trying to figure out what it is. But again, it's this creamy underbark here that the lightest bark, that's the photosynthetic bark. Because, again, these are growing in darker environments. It's an understory tree. So, again, it somehow needs help developing sugars. And so it would do this. Oddly, the outer bark is the most green, but it's obviously the less photosynthetic. But anyway, just fun to look at. Look at the flower on it. I mean, again, so you got these wonderful flowers that appear June into July. You have great fall color, and it's just a great plant to add to the garden for year-round interest. Now, Stewardia monodelpha I almost like this one better because it has nice orangey bark, much like paperbark maple. It'll grow. It actually prefers really wet environments. So if you have an area by a downspout or a low-lying area, Stewardias actually prefer and tolerate quite a bit of water. But look at the underbark. This is down at Chanticleer Gardens. Everybody was going behind the bamboo as bathrooms. So everybody was running off to the bathrooms when we were down there. And I'm like, look at this bark. You have to keep taking pictures. But again, see the green underbark to it. So again, this is photosynthetic bark, and still has great fall color, still has great flowers. But now you have an orangey bark versus the sort of the camouflage bark, and there's the fall color on it. Then we have scale or platy bark, and I think no tree sums this up better than shagbark hickory. And I've always, we have them right here on our street, the urban farmland, so there's hedgerows. But the Caria, very, very dense wood, and it has a lot of fiber in the bark. And so as a result, it doesn't pop off in the periderm, as the fibers in it doesn't pop off in patches. It actually comes off in these strips. And I think it doesn't have the color of Stewardia, but it certainly has the interest. And, I think always a fascinating, great fall color to boot. Kentucky coffee tree, another one which has somewhat platy bark when it's young. Bruce Hamilton, if anyone remembers Bruce, he taught woody plant class down at Rutgers from the late 60s through the 90s, I think there. But he always said that the bark looks like you took your thumb and put it into it like in Play-Doh and sort of created this indent in it. So again, it's more of a longitudinal peeling, exfoliating when the bark is young. And then as you can see to the right, as this is down at the Tyler Arboretum on the right, the bark becomes obviously much more ridged and furrowed with older age and more protective. But to me, the real fun of Kentucky coffee trees. And it's a hard sell because the plant, in the summertime, it has a very interesting leaf because this is not the leaf, this is not the leaf, this is the leaf. And so it has, and if you ever wondered why would a plant put so much production into one leaf, um, and it's one of the reasons behind it, though, is that these small leaflets keep the leaf cooler. So this plant probably initially evolved in a more southern locale, which was hotter. And so this type of leaf kept the whole system cooler, so it didn't lose water during the heat of the day. But again, it gives a nice lacy texture. I mean, look at that. I mean, that is just, it looks so tropical, even though it's perfectly hardy in New Jersey. And then as it grows older, it gets a very coarse texture, especially in the wintertime. And this is what people don't like about it. They go, oh, I like the summertime because it was nice and lacy, but look at the wintertime. Oh, it looks so coarse. I don't like that. And so people who aren't into plants tend to have a tough time with this. But again, this is in the pea family. You can grow it in the worst soils in the world. I've grown it up at Crystal Springs in subsoil, and that's up in Sussex County, New Jersey. And right next to it is a path that's highly compacted, and the plant did not care in the least. So a really, really tough tree that I think should be used a little bit more frequently. So there are males and females on it, by the way. If you don't like the pods of the females, there's someone just mentioned, yes, they have a green inner goo to the pods, which kids love, but I find a little yucky. But the Native American Indians also would play a game of marbles with the seeds because they're round, and you can also make a really rough coffee out of it, which I've never had, and I don't think I ever will. White oak, another great plant for nice platy bark, long-lived. Look at that bark on that. Look at the structure on that. I mean, that's just a cool tree. But again, very similar to the shagbark hickory, fibrous coming off in long plates. Really, really pretty. And I don't think most people would call oak trees pretty, but I think that's just, really fun. And again, a similar structure to the bark. Now, peeling bark, again, fibrous, but pops off a little bit more. And 7 sunflower, heptacodion, is a large shrub or small tree out of China. It looks very unsexy in a number 7 container, so it really hasn't made much strides. Produces a very fragrant white flower in late August and September that the bees absolutely adore. The honeybees and bumblebees. The calyces expand as you get into late October and November and turn red like this. So they provide late season ornament. And then as you get into winter, you get these long strips that come off. And this is the state champion. It's up at Frelinghuysen Arboretum. And I've joked with everybody because I said, well, this one's pretty good. I always thought we should call it strip tease because the bark comes off in long strips, and I think that would be a great seller for the plant. Who knows? And I've become less infatuated with crepe myrtles over the years. They still, and only because I'm more focused these days on native plants. And I've sort of seen crepe myrtles get overused, so I'm not trying to insult anybody. I'm just saying what my thoughts are. But Fantasy is down to J.C. Ralston Arboretum. It was an introduction that he brought to the United States from China. And again, great bark to it. I mean, you can't deny this. Very tough bark, grows in the worst of conditions. And so you have to give that to crepe myrtle. And Fantasy is another one. If you stumble on this one, look at the bark on it. Again, white flowers, full sun, poor soil conditions. It's fine and does fine and average to rich soils. Part shade to full sun. Well, look at this one down at the Scott Arboretum. I remember I introduced a college roommate of mine to river birch, and he was totally appalled at it. He looked at it. He was an electrical engineer, and he looked at it. And he goes, "Why would you want that? I would take a belt sander to it." And I never forgot that, and I would love to hear his opinion on this one. He'd probably totally hate it, but I just think it's fun, and how the bark exfoliates and peels. Bald cypress. If you're looking, and one plant that Saxodium distichum, the taller and the bigger of the two species that are native to North America, certainly has the more reputation for and knowledge and wherewithal. But ascendens is pond cypress and is more narrow. This is a 100-plus-year-old example up at Smith College, and it still develops the knees in wet sites, but in dry sites you don't get any of the knees. So here you have the bark at Smith College. So here you have a 30-year-old plant down at Longwood Gardens, and here you have a 100-year-old plant up at Smith. And again, you can see the bark comes off in strips, rather similar actually to our Eastern red cedar. But look at the fall color on it. I mean, just has great texture. And I've always stumbled as to why people don't like this plant more. It grows in poor soils, high silt. Will grow in sandy soils. It'll grow next to roads where it gets salt. So this is up in blah, blah, blah. Where am I thinking here? We're up in Sussex County at, well, why am I blanking? I worked there for years. But Crystal Springs. And this is the same plant a couple of years apart. And you can see how it's, after 10 or 15 years, how it's really matured and nicely. So, and great fall color. So anyway, Thuya plicata, Western Arb. If do bald cypress knees allow for photosynthesis? No, they don't even do gas exchange. So they originally thought that the knees on fall cypress were there and they're only produced in wet sites. So the original thought was that they come up for the exchange of gas. That was denied, and because they cut them all off and they found that the tree didn't suffer one bit. So what they think it does now is it actually comes up through, it's very deep rooted, comes up through the muck and the mire and acts to stabilize the plant. So in high winds, it doesn't topple over. That's one of the current theories of what's, why you see the knees produced in wet sites. Thuya plicata, this is down at Longwood Gardens. It has great bark. Look at that bark. Oh, again, comes off in nice longitudinal stripes and strips. It grows very well in New Jersey. We have it growing in Sussex County. I planted it at Willowwood Arboretum and Frelinghuysen in Morristown. Orange, very appealing, and no pun intended there. And if you get to go out to Olympic National Park, visit the Hoh rainforest. I mean, look at this. I mean, it's like you just went to another world. This is in August, and that's the family right there at the base of the tree. But there's my son sort of wedged between two trees. Look at the size of them. And if you buy cedar in a lumber yard, you're typically buying Thuya plicata. But just has wonderful bark to it. And so this is one of those trees, as it ages, first you use it as a windbreak, and then you start to elevate it so that with age, you really get to appreciate that bark. Cool stuff. Then we have smooth bark. And I hope no one's getting bored yet. But there's a lot of smooth bark trees. So here's Acer palmatum, Japanese maple, and all bunch of different types here. And this is that Willowwood Arboretum before we tore down really thought that the notification billboard there was sort of distracting from the tree. So someone actually hit it with a snowplow and took it out. So that was actually a good thing. Color, either orange or reds. You have to love that. It's a great understory plant. But the bark on it is really quite interesting. No one's bored. Oh, good. And look at bloodgood here. You see these stripes coming up the plant, and I researched and looked and looked and looked, and I think that those are lenticels, and as they come up, one of the best examples I've found is at Willowwood Arboretum. And so I'm encouraging, if you're close to Peapack Gladstone, to make a visit there. So this is one called Waterfall. And Waterfall is a seedling that the Tubbs brothers planted back in the 20s on a little berm next to a pond. And it obviously is still growing well. It's a very commonly cultivated species. You'll see it down at Longwood Gardens. This is where I photographed the flowers of Waterfall. But it develops this awesome architecture as it ages. And that twisting and turning of the bark obviously requires a lot of oxygen for the cells to divide and to develop. And when you look at the bark, look at that bark and look at those lines of lenticels. And I can't help but think that it just needs a lot of oxygen to develop and to strengthen as it grows. And look at the wrinkles that you get often with smooth bark trees. So with smooth bark trees, they don't shed the outer layer as much, the outer corky layer. And as a result, the periderm stays put. And as the tree turns and starts to twist, just like your skin, it wrinkles, it compresses it. And so you get these wrinkles forming. And I just love looking at things up close like that. If you like hornbeams, Carpinus caroliniana, they develop Arnold Schwarzenegger type arms, and you get this fluted bark. And again, if you were to carve it, the carving would not go away because again, it doesn't shed its periderm. It keeps that bark forever. Which again, paper bark, maple, all that, they're shedding the bark, whereas these don't. An old European hornbeam. To me, this is befitting of a cover of National Geographic magazine. Some plants just look old as they age. Sugar maple is one of those. This to me, is a very characteristic old tree. So, which someday I will ultimately become, I hope. And then we have Celtis. Celtis is one of those trees that doesn't seem to get any respect. It's one of the Rodney Dangerfields of trees. I don't know why people don't plant Celtis more, but it has smooth and then bark, but then the periderm shows activity in localized areas. And so that's why when you look at it, it'll have a pebble-like appearance to it. So it's smooth, and then all of a sudden you start to get these bumps on it. And this is literally in my backyard. It's in a wet, swampy area. But it developed these wings on it, which I just think are really neat. Winged euonymus obviously develops something similar, but it does it through a totally different. It actually has tears in the outer cortex where the the outer cork layer, and then the cork will grow up and through it. And so you'll get a totally different appearance. So that's why when you look at winged euonymus and you see those four wings very geometrically throughout all of the plants, that's the reason for it. Whereas this, there's a lot of genetic variation. So you get everything from strong wings to just pebbles. Yes, young sweet bums, also very interesting wing bark. So, and there's a reason for it. I don't know the reason. So why the plant doesn't do that as it ages. But again, there's always these secrets you have to figure out. And look at the European beech and American beech. Definitely don't want to lose these trees because what beautiful bark as they age. And as I mentioned before, the branch attachments cause wrinkles because the tree, as it grows, it's pushing downwards. So all of this elephant hide-like bark is because the original periderm never goes away. So it persists. So the original periderm stays. It grows. Yeah, stretch marks. Yep. And fun way to look at it. I like it. And as a result of that, you get these wrinkles. It sort of looks like something out of Indiana Jones, that one monster that get his name, but he had similar skin to that. And then that's why you always wonder, well, why don't all the carvings go away on beech trees? And that's because the original periderm is never shed. It's always there for the life of the tree. So and supposedly Daniel Boone carved his name into a tree, and so it's still here several hundred years later. So Magnolia grandiflora has kissy lip lenticels, smooth bark, as do all the magnolias, but sort of fun to look at that. Great foliage, great flowers, great fragrance. Look at that flower. I mean, does the carving harm the tree? Usually not, because it heals from within. So it just harms us. It just looks bad. And what's interesting about magnolias is that this flower developed with beetles. Developed about 120 million years ago. Lori knows all about this, so we should actually have her pop on. But so it developed before pollinators. It developed before bees. It developed before birds. So this is a plant that was, and so it adapted to bees, but it was not evolved with them. And then when you look at the seeds, these were not originally attracted by birds. We don't really know what was attracted to them, but birds weren't around then. So it was something else, and they come out and hang by a little thread. So the next time you look at magnolia seeds, you're looking back 120 million years in time. So I think that's just pretty fun. So all the magnolias have this smooth bark to them. So again, the periderm stays with the plant for the life of the plant. And when you're looking at the flower of a magnolia, you're looking at tepals. The outer layer is actually modified leaves that are bracts, which are leaves that resemble the petals. Pretty neat stuff. And close up of the bark. And even our native Magnolia virginiana, same thing. So with a smoother bark to it. Ridge and furrowed bark. Now, I showed this on the front page. This is ginkgo biloba. This is back up at Smith College, and where they have a lot of nice 100-year-old plants planted by Frederick Law Olmsted, or designed. I'm sure he didn't plant it, but photographed it in 2014, planted in 1901. And look at that bark. And when you look at that green strip down the bark, that's showing you the path of water. And so you say, well, what would be one of the functions? What would be one of the purposes of having ridge and furrowed bark? Well, it directs the water down just like canals, down the branches to the trunk, and then down the trunk to the root system. And which obviously then you have different growth of fungus, bacteria, mycorrhizations, and the soil. So it has a purpose to it. And when you look at the leaf structure of a ginkgo, this parallel formation of the veins, as opposed to a netted formation in an oak or a maple, this is very primitive. And if you look at ferns, they have the exact same leaf structure. So this shows you how the plant dates back 280 million years, give or take. So really cool old plant. And the fun thing about it is that when the leaves turn yellow, they all drop in one day. And they look great covering the ground. So easy plant to clean up after, because you get leaf drop over in a couple of days. But it's just fun to see the leaves raining down on you. Oxydendron, one of our native sorrel trees, great for late June and early July flower. Down in the Carolinas, it'll get up to 60 or so feet in height. Ornamentally, it gets up slightly shorter than that here in North Jersey, but fragrant flowers, sort of look like lily of the valley. But look at that ridge and furrowed bark. Oh, so that looks so rugged, and the plant looks so soft and totally different texture to it. So interesting yin and yang there. Look at the fall color. This is down at Chanticleer. You can't help but love that. I mean, that's just awesome. And look at that. And even the seed pods show up nicely against the deep red fall color. So great plant, needs to be used more. It just takes a while for the plant to figure out whether it wants to be a tree or a shrub. That's probably its biggest problem. Cork tree, which if you just plant the male, you're not going to get any seed production or invasive qualities. Otherwise, the females can become invasive. But the Roy DeBoer, who was the chair of the landscape architecture department at Rutgers for years, he loved the flat-topped appearance of the plant, but it's the bark that is just so cool about it. I mean, it really does have deep, soft, cushy bark, which is great. And you know, it takes a few years to gain that, but still fun to touch, and always put it by a walkway where you can touch it. Even sassafras, which develops nice colonies, develops yellow flowers in April to May, good for pollinators. It also develops ridge and furrowed bark, which you don't typically think about it as, but and it gets to be a significant tree. There's a huge tree at Frelinghuysen Arboretum, a good 60 to 70 feet tall with a DBH somewhere around 1.5 to 2 foot. Beautiful plant. Here is the grove in summertime. So sassafras, just a great one. And who does not remember learning about the mitten-like leaves when they were kids, and all that great fall color to it. Sequoia dendron. So Hazel Smith lived in New Jersey. She lived in Watnung, had a nursery named Watnung Nursery. Had some Sequoia dendron giganteum seedlings that she left out overnight on a very cold night, and one of them survived, and so named in her honor. And it's this is a big one at Frelinghuysen Arboretum. It's evergreen, as you can tell with the snow on the ground. Sequoia dendrons typically do not do well here in New Jersey, but this is obviously doing very well and thriving. And turn off my phone so it stops beeping. But it's the bark on it, great foliage, nice bluish color. Again, you can see the snow in the background. But look at the bark. It's spongy and it is thick. So it can get well over, as the trees mature, it can get well over 6 inches thick, but it is fire retardant. So it just develops paraderm layer on top of paraderm layer upon top of paraderm layer. And it's just great to put somewhere so that you can touch it. And that to me is just the beauty of the plant, is going up to it and seeing how soft and pliable the bark really is. We've mentioned lenticels, and some, now obviously all trees have lenticels, but cherries are really well known for that. Okami is one of the earliest bloomers. You know, very showy, typically late March, early April. It's out in full flower, but has that great bark. And again, those lenticels allow oxygen into the plant and CO2 out, but here they just appear in showy bands so that they're more ornamental. Tree lilac, Japanese tree lilac, which can seed around a little bit, just forewarning, but produces flowers in late May into June, so it's one of the later bloomers. But again, I find the flowers to be attractively fragrant. Some people don't like them, so you know, to each their own. But and it blooms in alternate years, so it'll bloom every year, but you'll get a bigger or a massed production of flowers in alternate years on it. And it too has nice lenticel bark. I photographed this at Willowwood with a few lichens on it, which aren't doing any harm, but they're just looking cute. And so it has nice bark. And if you can get Syringa picanensis, which is a close cousin, it has more exfoliating and peeling bark in addition to the lenticels. So adds a little touch to it there. And then colorful bark, finishing up. But so this may not be your cup of tea. This was a dead weeping hemlock down at Swarthmore, and so they decided to make it ornamental and paint it purple. So yeah, probably not so much. But if you look at certain trees, like this is a selection of Japanese maple named Sangukaku, the newest growth is red. If you look at red maple, it's a rubrum. The newest growth is red, but it turns red in wintertime. It is not red in the summertime. And so when you look at that, and here it's in flower, and you can see some of the reddish bark as it starts to turn back to summer. And here it is in winter. So why would red maple and Japanese maple have, like this one, have bark that's red in the winter? And it is a means of protection. So when you are looking at this, the bark turns red as it develops anthocyanins, and those anthocyanins are just like blueberries are improving our health. They are preventing damage from UV light, because again, Japanese maples typically grow in shaded environments. Red maples, for whatever reason, that obviously they grow in full sun, Acer rubrum, but again, the youngest tissues turn red on them. And, you have that ornamental interest in the wintertime, which, again, when I saw this and used it 30, 40 years ago in a design, I couldn't really figure out why it was, but I said, oh, well, that's nice. And then you start to think about it over time. It's like, yeah, there's a reason why they do that. Acer tegmentosum or Acer pennsylvanicum are striped maples. They have green bark. And the same thing again is that bark is photosynthetic, but they have this white stripes in it, which is actually wax. So that's part of the cork layer that's developing becomes very waxy, so that's suberin rich. And when they're young, so Acer pennsylvanica, we tried to sell these at Rutgers Gardens and the plant sale. It's like, oh, these are gonna sell because everybody wants native plants, and these are such a cool plant with the striped bark and the new growth being red. They're gonna be the hottest sellers. And bought in 20 of them, and we sold 5. So not every native plant seems to be popular, but in any event, again, the striped bark maples typically have large leaves because they're understory plants, photosynthetic bark, but the youngest bark, especially in the wintertime, turns red because as the leaves drop, the new growth is now exposed to sunlight, and to prevent damage, they turn red. Same thing with red stem dogwoods, native or orange striped maple, somewhat invasive. I have not had that experience. In fact, I've had a hard time keeping Acer pennsylvanica going. It's it grows quickly, and it usually fades out after 20 to 30 years. And I've seen a number of them around northern Jersey, and haven't had problems. So maybe not, and I don't know what species that you have in Pennsylvania, but if it's pennsylvanica, it's one that you want. So native. So again, the same thing is true with the yellow or the red, stem dogwoods. Again, if you look at the bark in the summertime, it's not red, and then as you get into colder seasons, they start to turn red, and that is in fact the anthocyanin development. Same thing is true of some of the willows that have red stems. And again, those red-orange stems are most ornamental in the wintertime when it's cold. Another interesting plant to look at, and I just literally photographed it yesterday. I didn't put it in the show, but Itea virginica. The stems turn red in the wintertime, but they are red on the side that faces the sun. On the side that faces away from the sun, they're still green. So again, they develop the anthocyanins on the side, obviously where it gets UV light, and it's potentially damaged. So again, I thought that was sort of intriguing how that could happen. So again, the more you look at plants, the more you sort of read them. And if you do the willows, you can see that as the weather warms up, they turn more yellow and then back to brown. But usually with the red stem dogwoods and the willows, we or cut them back hard in late winter to encourage a new flush of growth. If you have deer, typically I would take a third of the wood out, especially on the dogwoods. The willows grow so rapidly that they're easy to cut back. But with the red stem dogwoods, if you have a heavy deer population, typically take out about a third of the older stems each year, because because the existing stems will protect the new growth as it comes up from deer browse. Just an easy way to work with deer. And you can see on the willows, as the plants age, it turns more of a corky brown. Again, it's getting shaded by the stems above, so it doesn't need to develop the anthocyanins quite as much as the youngest growth. And that's one of the reasons why, for ornamental reasons, you really want to cut the willows back hard. So, so going through all this, I still have to always chuckle. And if you've ever heard me speak before, I always end up with my children. And I always love this image because that was before she was allowed to use makeup. And didn't have one wrinkle. She's turning 27 on Monday. I can't believe that. Yeah, she's a Christmas baby. And still no wrinkles, and that's somewhere in high school. And this was when we were out whole rainforest, but none of them turned into botanists or horticulturists, but they have a deep respect for nature, and I really couldn't ask for anything more. And so one thing that we always want to do is each year we go out and visit another national park. May or may not have trees, but it really has interesting and cool plants, and that's what I lust for. So and a little bit of that rolled off on my children. So anyway, hopefully that gave everyone a little insight into bark. There, as I said, there is no one way that bark is created. So as you walk around and look at beech or ash or maple or whatever, each one is created, crafted slightly different, because you have to remember they evolved over millions of years, and so as a result, they all look different, and so I took up studying bark a long time ago, but I really looked into how it's crafted in the last 5 or so years, and every time I turn around, I learn something new. So the last thing I learned, and I'll leave you with this: it's not necessarily bark, but and it's not native, but if you ever grow umbrella pine, I found out that the whorls of what I always thought were needles or leaves are actually green stems, and so they're modified stems, and so it's they're called cladodes. So I thought that was really, really cool. So, in any case, you're going to embark on new invasion. Oh, that was a bad pun.
Very nice, Bruce. Very nice. Thank you. Well, I know I'm never going to look at a tree the same. I'm going to stop sharing this so we can say hello to everybody again. Thanks for sticking with us. Holy crow, there's like 54, 55 comments in the chat. I know you were asking or answering some questions along the way, and I couldn't really get to it because I didn't want to mess up the screen. So do we have time for some Q&A?
Yeah.
Okay. So
Lori, I thought there were two questions that were interesting. One, Bruce, you alluded to the problems with beech. Maybe you could expound on that a little bit.
Well, the beech leaf disease has become quite an issue. They aren't truly certain what the problem or the cure is, but what they've been looking at is it's potentially an insect that gets into the between the and they've been finding out that if one of the simpler cures has been to remove the lower branches of the tree, which just doesn't always work. But as the water splashes the ground, the disease and the whatever potential for getting inside the leaf comes up from the soil. So by removing some of the lower branches, that does help. There are certain tree companies that are starting to develop some techniques. They found out that a higher phosphate potential application of fertilizer does have some positive impact on the tree, but it's still really early in the development of the disease, so there's not a lot of knowledge out there yet on the problem.
Thank you. The other question that I thought was interesting was we encounter situations where bears tear bark off a tree and rub on the tree. And is there any way that you would recommend to repair bark, or did you just have to let trees seal by themselves, or is there
Yes.
sorting tanks
So
to
there's
repair?
once the tree is damaged, there's other than cutting the ragged edges so that it's a um, clean cut, so to speak. Um, there's really you don't want to put tar or paint on the trunk, the damaged part. What they found out that actually allows the growth of various bacteria and fungus underneath it, because it'll crack and then allow the bacteria in. So you just want to let it weather and heal as best it can.
See what else?
Bruce, I don't know if you can see the chat, but there's a lot of praise and a lot of people saying hi, good to see you again. Some master gardeners say hello. Mom County, right? Richard says, thanks for your barking lecture.
So someone asked about planting around a pond. I didn't do that, so I wasn't involved with that one.
Okay, Kitchell Pond. Where is
Yes,
that, Bruce?
I don't know.
Okay. Okay, Dorothea, if you can, where is Kitchell Pond? Maybe pop that in the chat. We'd love to know. So, Rich, anything else you see in
I see Jim Kilgore, actually one of our directors, asked for is there any good reference material on what was discussed tonight?
What was the question?
A source of reference material for what was discussed tonight.
I have gone through so many different scientific papers. There is, I think the biggest problem is that a lot of the reference material is so scientific oriented that it goes over. It's hard to decipher it and understand it. So I put together a small handout, which I know Lori is going to send out shortly, so that will condense tonight's talk into 6 pages. And then, but I can't point anyone in to a certain book because there wasn't one source that had all the information in it.
So we'll just have to keep coming to your lectures then.
Or just, Googling scientific papers is great because they're really based on not just hearsay, but they're based obviously on research.
And Carl put a link in the chat as well, a digitized database of bark morphology for ID of common tree species and stuff.
Okay.
So it's worldscientificnews.com. So that might be something I could carry that over into our follow-up email with your handout.
Okay.
As well. So we can talk about that. So apparently Churchill Pond is in Lone Tucka, I'm probably saying that, Loantaka Park in Morristown and Madison. So you should be able to go visit while you're at Frelinghuysen. Go check that out, right?
So,
anything else that we can say? Yeah, and Tammy mentioned setting up a pamphlet for us. So yeah, what everybody that registered, I will follow up not only with a recording of this presentation that I'll send you a link that when it gets popped up onto YouTube, but also the handout that Bruce produced. So that'll kind of give you a summary of everything that was talked about, which is great.
but here's a funny question. What's the forecast for ash trees and EAB? No, there's no forecast. It's over.
It's done. Yeah.
Over and done.
It's a shame. Yeah.
It is. And,
there was another thing I said. Marion was saying, I see now even more reason to remove English ivy from trees.
Yeah, that's actually good because it prevents English ivy from becoming invasive because it goes up the tree, it flowers, fruits, and it doesn't harm the tree, but you still want to get it off the tree.
And then you can't see the bark, right?
Right.
Hello, right? Taught me well. It's all good.
Okay, well,
Okay.
I think that about wraps up the general questions.
Yep, sounds good. Sounds good. And for those that have, I see there were a couple of questions about CEUs too. Just reach out to me. The CEUs like community forestry, they actually go and get a attendance report, so you shouldn't have to do anything. If anybody needs a certificate, I'm happy to provide it to you. So just let me know. Send me a quick email on that. And Bruce, thank you so much. This was fascinating. I definitely will not look at bark the same for sure. And the lenticels and all that, yeah, it's just not going to be the same anymore.
And so what Marion Jordan said too, yes, English ivy would make photosynthetic bark more difficult to be photosynthetic.
See,
Good job, Marion.
we learned. That's great. Uh, all right, excellent. Well, thank you, everybody. So glad that you were with us tonight, Bruce. Thank you as always. Great presentation. I think you like trees. I sense that a little bit in your
A little
talk.
bit.
A little
A little
bit.
bit. Thank you so much.
Yeah, good job. Thank you. I
Thank
wish
you.
everybody happy holidays, and I look forward to seeing you in 24 for a whole nother year worth of great backyard forestry programs. So thanks, everybody. Have a great evening. Stay warm, and we'll see you next year.
Thank you. Happy holidays.
Happy holidays.
Take care, everybody. Thank you.
Thank you.